Again, I'm here with Yali from Snowplow to discuss game analytics on AWS. I'm going to use a number of real-world game analytics examples to discuss many of the concepts, and both Yali and I will do a couple demos here. I'll start, then Yali will present, and finally we'll do some questions and answers live. And again, at the same time, like you heard, please feel free to ask questions as we go along in the chat. All right, what is the goal of analytics? So there's clearly a lot of goals here, and I'm probably preaching to the choir to a lot of people here on the webinar, but I would argue it really comes down to creating a more engaging player experience. And that, of course, leads to things like attracting more players, increasing their enjoyment, and finally encouraging purchases. I have an interesting quote from Supercell here. They said that their games don't stay in the top 10 list automatically, which is obvious. Their success has to be earned. And they do that by providing additional features, balancing the game, things like that. There's this quote here from Peter Drucker. We seem to use it in a lot of our analytics presentations. It's if you can't measure it, you can't improve it. And to me, that kind of means that when you are doing analytics, when you're running a game, if you don't know whether you are successful, or you don't know whether you're successful unless success is defined and measured in some way. You need metrics for success so you can see the progress and adjust things to produce the desired outcome. Without clear objectives, you're really kind of doing a lot of guesswork. And that's kind of what that means to me, and I think that fits well with what Supercell is saying. All right, we have here a screenshot from the game Breakaway, which is a game by AGS, Amazon Game Studios. It's a 4v4 battle arena game. There is in the center a area where there's a thing called the relic, and the goal of the game is for each team to take the relic to the opposite team's relay. This thing is the relay, and you can see the player here standing in their relay. There's also these ziggurats on each side, and those provide power-ups to the team. So as you're doing the analysis of a map like this, and you're trying to figure out whether or not this is a good map, whether it'll be appealing to players, one of the initial questions you may ask are, where are all the deaths occurring? Where are most people dying? Because if the deaths are too spread out evenly across the map, it may imply it's kind of a boring setup. If they're too concentrated, it may imply that the players don't find certain areas interesting enough to explore. So we start with a question when we're doing analysis, and we make a hypothesis. And the hypothesis here is that probably most of the deaths occur in this runway here, between the relays and where the relic is. And we'll probably see some deaths up on the ziggurats, so people get the power-ups. So that's our hypothesis, and we would, of course, use data to then analyze that. What Breakaway did was they built an app to generate a heat map from the data they have in Redshift. The map shows the concentration of deaths in this particular case, but they can use it by using the right parameters to really kind of display any information about this map with the data overlaid on it. This is the SQL query they use to generate this particular map, and it kind of creates these meter by meter hexagon squares of the number of deaths. And the fewer deaths are kind of the darker areas down here, and more deaths, you get to the lighter colors up here. All right, so we want to look at this and understand whether or not our hypothesis was correct. Well, we do see that there's a lot of deaths occurring in that runway area in the center of the map. That was expected, that's good. There's a few things, though, that showed up that weren't expected. One thing is that the ziggurats, where that power-up is, we're not seeing many deaths at all. So it's implying that either the players don't see the value in that, or it's just not worth the risk, because really it's all about getting the relic to the other team's relay. Another thing that occurred is that the pathway down from the ziggurat, we do see a number of deaths, these kind of clusters here. So these are stairs down to these areas, and that's very unexpected. Why is that occurring? What does that mean? Is that good or bad? But without this kind of data and then the analysis that you can do, it's really difficult to answer questions like that. And when you're able to answer questions like that, you can really improve a map design. And of course, this goes to a lot of different areas within game design too. Just want to kind of show you one way of doing analytics here. All right. Another reason why analytics is so important, and again, I'm probably preaching to the choir, is that there's this concept of games as a service, which is becoming bigger and bigger. And it's this idea that you have regular updates and a continuous production cycle throughout the entire product life. You're constantly improving it. And we see this in so many areas, especially in the big AAA companies. Blizzard in their recent Q1 revenue report said 80% of their digital sales 80% of the revenue comes from digital sales, and that includes things like microtransactions, which are very typical for games as a service. In 2016, EA said that their extra content business generates $1.3 billion a year. That includes downloadable contents and also season passes and microtransactions. Just this year, EA said that their games today are live services. They update and evolve to deliver ongoing fun over time. So they're definitely in that game as a service area. And finally, there's a quote from Newzoo that free to play will kind of disappear as a term in their view, that really every game will have an array of ways to spend money, and that the trend that's here to stay is games as a service. So without a way of measuring the success of the game, of changes you make, it's really hard to improve a game over time. And this is why analytics is just so important. All right, really quick, there really are 3 different ways of looking at data analysis. You can kind of think of it as an evolution. We're going to focus primarily on descriptive, which is the reports, real-time and batch that you generate, like that Breakaway heat map we looked at. But there's also predictive, which is the idea of kind of predicting what's going to happen in the future. And a lot of it's about looking for groups of users that kind of match certain things. For example, groups of users that you think may abandon the game. And then there's prescriptive, which is if X happens, what do you do? It's automation, oftentimes based on what you find in the predictions to take action in the game. And we'll get into the predictive and prescriptive just a bit at the end. All right, we did a quick intro analytics. I'm going to now go through the analytics pipeline with a couple of case studies. This is a generalized analytics pipeline. It starts with what we would call the telemetry, the events, the raw data from the game clients, the game servers. The end result is answers, but we first have to have a way of ingesting the data, some way to collect it. That's a very common model. And then there's usually an initial storage zone, followed by kind of the meat of the analytics pipeline, which is the process and analysis. And oftentimes you'll see a back and forth between the storage and the processing. And finally, you are consuming that data. And what you're really consuming are the metrics or the answers. And we'll look at this as we look at a couple of examples. So we're going to start with the ingestion and collection. And we're going to look at Star Wars Galaxy of Heroes. This is a mobile game. Very popular. They actually presented at reInvent last year on their analytics pipeline and some of the challenges they had and solutions they found for Redshift. So I recommend you take a look at that. All the examples we're going to talk about, I'll have links to those at the end, and also some links to some demos, so you can check out these and some additional ones that I'm not going to mention that I think are very interesting. All right, this is their full analytics pipeline. There's a lot going on. You can see a number of services here. Amazon Kinesis, of course, our fully managed service for real-time stream processing. We have S3, our highly durable object storage, data pipeline for processing, kind of mark through that, processing and moving data between compute and storage nodes. And finally, Redshift, which is our fast, fully managed petabyte scale data warehouse. We're going to get into each of these. I just want to kind of point out the services involved. So let's look at the ingestion and collection for Star Wars. So it starts with the mobile clients, of course. They are persisting the data locally, and then they batch it and send it over to the game server every minute or so. So we have this initial flow here. the game servers then kind of further batch the data, and there obviously is data being generated on the game servers, and that's then written to Amazon Kinesis. The actual app or service that's being run on the game server to do this is ActiveMQ. And they chose that because at the time it was the best solution that they could find for persisting the data to disk, and then also handling retries in case Kinesis either wasn't available or for whatever reason they had to do retries because they weren't getting the response. And then it also sends data to a dead letter queue if the number of retries is exceeding their threshold, and that dead letter queue is flushed every once in a while. So that's their flow for the ingestion. If we go on to Breakaway, this is their overall analytics flow, and you're going to see that there's a lot of similarities between these two. So for the ingestion, we do have that initial area, the game clients, which are PC games, are of course generating telemetry, sending it off to the game servers, which would be dedicated multiplayer game servers. The game servers themselves keep this in-memory ring buffer of the pending events, and then flush them out in batches to Kinesis just using the put records API. And you can see it going into the Kinesis stream there. Now, Breakaway actually has a second ingestion layer because they're using Kinesis a second time. And you can see here the second Kinesis stream. This is what they call the file stream. And what this is doing is the earlier S3 connector here, and you'll see these connectors as we go into the process and analyze, is writing S3 file pointers to their second Kinesis stream as it writes data into S3. And this is all part of the process of getting the data into Redshift. And we'll get into that in a minute. So we can see that Kinesis was used quite a bit here. It's a very common solution for the ingestion of data. There's, I would say, we can call them 3 flavors of Kinesis. There's the original Kinesis streams, which is commonly used for collecting and streaming data. It orders it within what's called a shard. It's replayable data and allows for real-time processing. Kinesis Firehose is kind of an extension from that in that it handles the process of getting the data off of the stream into your endpoint. So with Kinesis streams, you need a writer, you need to write to the stream, and then you need something to read from it, and then process and move the data to the actual endpoint. Firehose just takes care of that second part, the reading from the stream and putting it into S3, Redshift, or Elasticsearch. And finally, we have Kinesis Analytics. This allows you to actually run SQL queries directly against those streams and either view the data in real time or more likely send this off to another stream, which usually you're doing some kind of aggregation at that point, send it off to another stream and then storing it. So it allows you to do real-time SQL queries against that for doing some sort of transformation. And I'm going to switch over to a quick demo on Kinesis Analytics, and looks like everyone can see this. Just got to log in. So think of this screen as a real-time view of the latency of all the game clients you have out there. So let's say you have a kind of a worldwide, we'll call it a RPG because the latency is pretty high here, and you want to make sure that the latency from each of your clients on average is fairly low. So you have this real-time monitor. You can see North Virginia here, the average is 431 milliseconds, Tokyo 477. So it's using Lambda to generate this dummy data of these telemetry events coming in from the client. If we go into Kinesis, one thing we see is the results of the SQL queries that are running. So here's the actual SQL language, and it's just taking all of these individual telemetry events of the client reporting its latency, and it's aggregating it. So it looks at a 30-second window. It has this 30-second tumbling window that it examines. Once it's done with that data, it then goes on to the next 30-second window. And you can see the aggregate results here. So there were a number of these telemetries coming in. There were 6 of them at this particular time. in that 30-second window, and the average was 510. So you see those results there. You can also see the source data. So we have this raw data coming in, a timestamp, the region the client is in, and then the latency they're experiencing. And another one, and that goes on. And then finally, this data that you see here is written to another stream, ingested by a Lambda function, which then puts it into DynamoDB. And you can see the results here, and this is just like what you see on that web page, the region, the average latency, and then there's a count that's shown here. So you get this kind of real-time view of latency. Pretty simple because most of the services here are managed. We handle the underlying kind of complexity. You're just writing SQL to aggregate this data, and you get this nice real-time view. And you can see that this dynamically changes over time as we invoke the fake clients. All right, so moving on, we're going to look at storage. So back to Star Wars Galaxy of Heroes, there's a couple of areas that they're storing data. The first area, and this is obviously a very short-term storage, but you can kind of think of Kinesis as part of the storage flow in addition to the ingestion flow of a pipeline, because you can store data for up to a week in Kinesis. So if your next component is down for some reason, the next component here is the S3 Kinesis worker, and it's not able to read from the Kinesis stream, then the data is still available. Capital Games with Star Wars Galaxy of Heroes chose a 24-hour retention because that was what the limit was at the time they built their solution, but you can go up to a week. The other storage, and this is another common pattern you see in these analytics pipelines, is S3. That's our highly durable object storage for all the clients and from the game server for their long-term backup. They're also storing a flat JSON file, the data that's actually going to be ingested into Redshift. We see a similar pattern for Breakaway. We have that initial storage just in case the next item in the distributed app is down. You have the initial storage in Kinesis. And then you have the long-term storage in S3, which is also used for the data that's ingested into Redshift. So again, very common pattern that you see there.
What I've got here is a level dashboard that's been developed by the team at Code Combat to help them understand and develop their different levels in the game. So what you can see in this table is a list of rows where each row represents one of the levels in the game. And then we've got a whole bunch of metrics that really summarize play within that game. So across our different levels, we can compare the number of people who've started the level and completed the level and the completion ratio. So that gives some idea about the difficulty curve in the game and how many people drop out at different stages through the game. At the other end of the table, there's some really interesting, really important metrics, exit count and exit rate. So this is the number of people who left the level and never came back to the game, and then the percentage of those people, of the total people that played the level in the time period that we're looking at. And what this enables us to do is it enables us very quickly, enable the Code Combat team to spot levels that are driving particularly high dropout rates and prioritize maybe working on those levels, helping players through those levels to keep them playing the game for longer. And in the middle, you can see a whole bunch of other metrics that tell you other things about the game. So we're tracking the restart ratio, how long a player typically takes in each of the levels. Within the Code Combat game, there are hints. So if you get stuck, there are hints available, and we can see how often these are used within the game and how that compares actually to the number of hints that are available. And then if you make a mistake in the game, that's also recorded as an error. And so this is a pretty powerful dashboard for the Code Combat team. It enables them to quickly identify levels where there are issues and then start to form hypotheses about what those issues are. The other really interesting thing is this table started a lot simpler with a lot fewer metrics, and over time as the teams got more and more familiar with the data, they keep adding metrics to this table to build a more and more nuanced view of how that gameplay works. So what was really important for the Code Combat team was that they were able to develop keep adding metrics and keep adding dimensions to the game to the dashboard over time as their understanding develops. And that's a classic analytics on read feature. This ability to keep asking new questions of your data, keep going back to your existing data set and learn more and more about your game. So I now want to go into another demo, an analytics on write demo, where we're using the data within the game, and we really want to minimize query latency. So again, this example is taken from Code Combat, and I'll just load it up for you here. So what is loading here is a map of the game where you can see the different levels, and around each level you can see a particle cloud. That particle cloud represents the number of players that are live in each of the levels at this point in time. And where a player leaves the game or exits the game or moves from one level to another, you can see that represented by the particle moving from one cloud to another. So this is an example of taking that data from the data pipeline, computing on it, so computing the actual number of players in each of the levels right now, and then feeding that back into the game to improve the game experience. The analytics on write use case that I showed you, that real-time consumption of data through the data pipeline, that is really powered by stream processing on top of the event level data in Kinesis. So even before the data is written to any kind of permanent data store, we want the ability to query it in stream. And AWS provides a rich tool set for doing just that in the shape of services like Kinesis Analytics, which Greg talked you through, AWS Lambda, which is what the Code Combat guys used in that example, and things like Spark streaming on EMR. On the analytics on read side, where you want to query your data in as flexible and open way as possible, there what you really want is your underlying data set stored in a big elastic compute type environment with a rich query language. And there AWS services like Redshift, like Athena, like Spark on EMR are really invaluable.